In this section of the course, we'll take a quick tour of the CodeLite IDE interface. It's important to feel comfortable with the environment that we're using to create our C++ programs, so I'll walk you through the major functionality of the CodeLite IDE so you can get up and running quickly. Then we'll write our first C++ program. It'll be a pretty simple program that simply asks the user for their favorite number and then displays it on the console. We'll use this program to look at the build options provided by CodeLite, and I'll show you how they work and what they do. Finally, we'll introduce some problems into our program so that you can see some of the typical errors and warnings that you'll probably encounter as you write C++ programs and understand them and know how to fix them. That's it. This section's short and simple, but very, very important since it lays the foundation for writing, building, and running C++ programs in the CodeLite IDE. Let's get started. Hello, everyone. In this video, I want to give you a tour of the CodeLite interface. The version of CodeLite that I'm using here is 17.3.0. This version is more recent than the versions that I used when I recorded the videos for the course. Overall, they are very, very similar. Sure, you're going to see a couple of differences in the user interface. Some things have been cleaned up and made more streamlined, but the basic functionality of the IDE, namely creating workspaces, creating projects, editing the code, building and running the code, have not changed. So let me give you a quick tour here. When you first open up CodeLite, if you don't have a workspace already open since the last time you saved it, you'll get a screen that looks like this. Over here on the left side, you'll see the workspace view. This is where the workspace and projects will reside. There aren't any open now because I don't have a workspace open yet. Over here in the center, you see these 4 big buttons. Again, that might change in the future, but right now we're going to use 2 of them. We're going to open an existing workspace and we're going to create a new workspace. Down at the bottom, we can see recently opened workspaces. So you can see that I've already opened 3 workspaces, and I did that so you can see something down here. Very likely the first time you run CodeLite, you're not going to have any workspaces, so this section down here will be empty. So suppose I want to load a workspace. I can open a workspace and navigate to it, or I'm just going to click workspace 2 right here, which is a workspace that I created with several projects in it just to walk you through this interface. So I'm just going to double click that. And you can see that CodeLite has loaded Workspace 2 into the Workspace view. Workspace 2 has 4 projects in it. Project 1, Project 2, 3, and 4. Each one of those is a standalone C++ application. We can expand each of them. And you can see each one has a source folder. And within the source folder, they each have a main.cpp source file. That's where our C++ code goes. Later in the course, we're going to have projects that have multiple CPP files in them. Also, you can see that Project 1 is bold and italicized. That tells you that Project 1 is the active project. The way that CodeLite works is that it builds and runs the active project. So when we come up and build things in a minute, it's always going to build the active project. So it's really important that we understand what we're building because we could be editing Project 4 and then pressing build thinking that Project 4 is being built. But if Project 1 is the active project, Project 1 will be built. It sounds confusing, but it really isn't. Just make active what you're working on. It's really, really straightforward. Okay, so that's the workspace view. We've got some tabs up here. And the only one we're going to use is workspace. Don't worry about the rest. An IDE or an integrated development environment such as CodeLite is designed for small programs like we're going to do, and it's also designed for very large programs. So it's got a lot of bells and whistles that we're not going to use. These are the kinds of things you would use in programs that are thousands of files and very, very complicated. So in this case, we're just going to keep it really, really simple. This is all about learning C++ more than it is about learning CodeLite. So there's my workspace. You can see that I have this little paper airplane here. And when you click that, it collapses everything. Sometimes we've got a lot of projects in here and they all get expanded and it's really hard to find stuff. So if you click that, it just collapses everything. Now I can expand whatever I like again. Also, if I'm somewhere down here, let's say, and I want to go to my active project, I can just click that home icon and that takes me to my active project right away and opens it up. So that's kind of handy. And you've already seen the settings. You can click the project you want and you can click that little wrench and it gives you your settings. We did that when we installed and configured CodeLite a few videos ago. All right. So that's the workspace view. Now, this big area right here in the center that's got nothing in it right now, this is your editor. In order to use the editor, you need to click on a C++ file or something in the project. So in this case, I'm going to double click on main CPP and it opened it up. And you can see this is very similar to the program we wrote during the installs. Hello from project 1. Makes sense. Now let's say I want to open up project 2 and I want to open up that source file. That loaded up as well and it says hello from project 2. Up here in the tab, we can tab between those two. And as I do that, you can see this blue bar over here in the workspace view jumping to the appropriate file in the project. We can turn that off by clicking that little link right here. I don't know why you would want to do that. I love the fact that I can see exactly where it's at. So I'm just going to leave that alone. We can open up the rest of these projects as well. Let me expand all of these and I'll open up project 3 and project 4. So now you can see that I've got 4 project main CPPs open up here and it's pretty easy to see which project they belong to. And you can actually hover over it and it tells you the path to the workspace and the project and the file within the project. Okay, so that's great. When I modify the code, and again, let me collapse all of these and I'm going to go to my active project. And there's project 1. So that's where I'm at right now. I can close these up now just to get them out of the way. Right now I'm working on project 1. When I make any changes to this file, for example, suppose I added a space at the end of this line. We get this little red dot right there, right next to the project name in the tab. That tells you that this file is called dirty. So in other words, what I'm working on right now is not what is on the file system. So it's telling you right there, hey, be sure to save this if you really want this updated on the disk. So we can save with file, save file, or Control S, or you can click on this little save icon right up here in the bar. And I'll talk more about that control bar in a moment. So I can do that. I can press Control S and that little red dot goes away. If you're on Linux, it's a little black dot on most of Linux distributions. But again, it doesn't matter what color it is, but you're not going to see that little X to close it. So that's my project 1. Let me remove that line. And again, you can see that that's red and I'm going to save it again. So this is how we would edit our program. I've made this font large so that you can see it better on video. All of that is in the settings, colors, and fonts. If you click that, you can change the fonts, the colors, the theme that you're using, whether it's a light theme or a dark theme and so forth. I'm just going to leave this alone. We've already learned how to create projects. We've learned how to create workspaces. We did that in the installation video. So that process is exactly the same. Now, how do we build and run? Well, let me expand this. Right now, project 1 is the active project. So we can come up to build and we've got a couple of options here. You can see we can run, we can build the project, we can rebuild it, we can clean it, we can do a whole bunch of stuff, right? We're only going to be using a couple of these, actually probably just one of these most of the time. In order to create an executable file that we can run, we need to build the project. And in order to run an executable file, we have to have a good build. No syntax errors, no other errors. You can do that by pressing F7 to build the project. So let me do that. And the output view opens up down here. I'm just going to scroll this up just a little bit, move it up so you can see it all. The output view opens up and we get our build output here. You can see that build output is in this build tab. If you post on the Q&A forum saying, hey, I've got some kind of error, it's not building, I'm going to ask you to show me the build output because that tells me what's going on. So this is the build output. Notice successful build, no errors. Once we have a successful build, we can come up to build and run it. Now it's going to ask me, would you like to build the active project before executing it? I've already built it, so I don't have to build it again. You certainly could. And if you want to always do one of these, just remember your choice and click that little check mark, and it's not going to pester you all the time with this little pop-up. So let me execute it. I'm building and running project 1. So I expect hello from project 1 to display on my terminal, my command prompt. Execute. And there you go. Hello from project 1. I should also mention that the process for Mac, Linux, and Windows is exactly the same. So everything I'm talking about in this video applies to all of the operating systems. When we're done, we press enter and we close that. So that's that. Now, we can modify the look and feel of, so for example, suppose I don't want my output view over here. Suppose I want my output view over here on the right. I can grab this blue bar. It may not be blue on your end, but I can grab that bar and just drag it over here. You can see it's lighting up right there. So I'm just going to drop it there. So there's my output view. And now suppose I want my workspace view to be above that, so I can just move that over there. So now I can have my workspace view over here, my output view over here. The view menu option gives you all kinds of options. For example, I can turn my output pane off, in which case you can see it's just disappeared over here from the right, and I can turn it back on. I can turn my workspace pane off and back on. This is totally up to you what your preferences are as far as the look and feel of your work environment. We can also do a view with the main toolbar orientation. That's the toolbar. That's this toolbar right up there, the one we see with the plus and the bug and all that. These are just shortcuts to things I've been doing. We can add a new file. We can open a file. We can save a file. That little hammer builds the active project. Here we can stop a build, which is not a big deal for us because our builds are pretty fast. But when we have really, really large C++ programs, builds can sometimes take an hour, believe it or not, or longer. So sometimes we want to stop the build for whatever reason. We can clean the active project, and I'll show you what that is in just a moment. And we can run the active project, and certainly we can debug it. We'll talk about debugging in a different video. So these are the main functions here. If for whatever reason you just get lost in this interface, you start moving these things around and, oh my goodness, I don't like what I've done and I'm having trouble getting back, you can always just go to View and Restore Layout. And that'll bring it right back to factory default, basically. So as I said, there's all the view issues here. If you don't like that main toolbar up here at the top and you want it on the left, you can just go to View, Main Toolbar Orientation, Left. And then it's going to say, do you want to reload CodeLight? Sometimes it's going to want to restart. So say yes, you can see what it's like. It closes up, it opens up again, and now you can see that the toolbar is over here on the left. So again, personal preferences there all the way around with the views. So now let's talk about the build again. In this case, if I want to build, what that means is I want to build the active project. So what CodeLight is going to do, it's going to go out there and it's going to see first, has it already been built? If it has been built, then it's going to say, has anything changed in the source code here since the last build? If the answer is no, then it's not going to rebuild it. It doesn't need to rebuild it since the build is current. Make sense? Now, if we have made any changes or it's the first time we build, it's going to certainly build it. So that's what build does. Clean the project, removes any intermediate files, the executables. It just basically clears out everything, not your source code, just the build products, cleans out everything. So the next time we build, we have a clean build. In other words, there's nothing pre-built. Rebuild does both of those essentially. First it cleans and then it builds. That's what I would encourage you to use throughout the course, Rebuild Project. The reason that we don't use Rebuild Project in industry very much is because our projects can be very, very large. And if I do a clean and then a build every time, it could take 20, 30 minutes. Whereas the build itself is only going to build things that have changed since the last build. So they're much more efficient. But for this course, I would encourage you to just select Rebuild Project. So let me do that. I'm going to click Rebuild Project. And you can see that the output view opened up down here. You probably didn't see it, but right before the build happened, the clean also happened. And the clean kind of looks like this. I'm going to select Build Clean Project. And you can see that RM means remove. So it's removing all the files in the build debug folder, which are all the intermediate files, all the binary files essentially. So that's the clean. Now we can come up to build again. Now remember, let me rebuild it. Now, when you see a build that includes G++exe, that's a real build. That's actually building the intermediate files. Okay, I hope this makes sense. Now, if I try to build again, just to build, notice nothing happened. There was no G++ command in there. That's because the project was already built. CodeLight realized, I don't need to build it. It's already current. So my advice is to always use rebuild. Okay, now we can do it at the project level, the active project, or we can build the entire workspace or clean an entire workspace or rebuild an entire workspace. So let me show you how to clean the entire workspace. You can see that. I just cleaned the workspace. So it's removing files from every single project. So you can see project 4, project 2, project 3, project 1. Now I can rebuild each project. I'm going to rebuild the workspace, and it's going to build everything for each project within the workspace. We're probably not going to use that. I just wanted to show you that it was there. Okay, perfect. Now, obviously, I can run project 1 again. If I make project 4 the active project, and I can do that by just double clicking it, just like that. And I can run it and go to build and run. I don't need to build it since I've built everything in the workspace already. I'll just execute. And we should see hello from project 4, and that's exactly what we see. Great. All right, so that covers the building. The debugger I'll cover in a separate video later on in the class. Let me close this output view down a little bit. We also have searching. For example, I could search for things within files, across files. I know that all these programs have a main in it, so I can find in files, and I can say I want to search for main. And press find, and then the output view again opens up, this time with the search tab highlighted, and you can see that I've got a main in project 1 and project 2 and project 3 and so forth. And if I want to go to, let's say, project 1's main, I could just find project 1 and click here. And there it is, project 1's main. I can go to project 2's main, and project 2 opens up here, and there it's main. So it's pretty handy to find things across files in your entire workspace in this case. You can clear all this by just clicking right there, that little broom, and clear it up. And that's my output view. It's got several uses. This build tab is probably the one we're going to use the most, and it's probably the most important one because that'll tell us if there's compiler errors and so forth. All right, so let me close this back up. Now the plugins, let's talk about that for a moment. There's really 2 plugins I want you to activate. They may be activated already, they may not be, but let me show you how to do it. You go to plugins and manage plugins, and let me close this down here to give us a little bit more room. Let's go to plugins, manage plugins, and there's a whole bunch of plugins, and plugins are just little external pieces of code and little programs that CodeLight uses. So the ones that I want you to check off for sure are language server plugin, make sure that's checked. And down here where it says wizards, make sure that's checked because we're going to use that later in the course. That's it. Hit OK. And when you come to plugins, it might ask you to restart, but you'll see those 2 plugins here. And the language server, you can basically go to settings and make sure that everything's enabled. It should be by default. And then you could restart the language server. And what that does is that helps you do code completion. So as I type, it's going to help me by helping me complete the code. For example, if I typed in some variable name here, and again, we'll talk all about variable names later. Let's create an integer called age. Let's say my age. Something like that. Let me put a semicolon here. Then later on, if I want to use my age, I can just type my underscore, and it pops it up for me, and I can just press tab and use it, so I don't have to type. It also allows us, let me delete this. It also allows us to use some of the C++ keywords and functions. So example, if I wanted to use a double, I could just do that, press tab, and create a variable name. So again, makes it very, very handy. It's kind of finicky sometimes. Sometimes it wants to work. Sometimes it doesn't want to work. What I've found is if it doesn't work, just rebuild, and then it kind of kicks it in. So that's the plugins. The settings, there's tons of settings here. We've already seen some of the colors and fonts. The preferences, we've got whether we want to display line numbers over here in the editor or not. We can turn that on and off. Highlight the current line number like that. You can see 7 is bold. Again, I'd just leave all this alone because the default settings are pretty good. I'll close that up. You can look through there. But again, don't just start clicking on things because your interface is going to get pretty crazy. So let me just leave that alone. Then the other thing you're going to see in your code is this little red thing, and it might be red, it might not be red depending on the operating system, but you'll see some kind of little icon here where we can click it and it collapses that. So you can see that it collapses that. Now that doesn't look very useful here, but when you've got a lot of code, let's say you have 500-600 lines of code, and you've got parts of your program that you're really not interested in right now, you're working on a different section, you can collapse certain sections to kind of just hide them, sort of. It's not really hiding them because they're there, but just kind of get them out of my way right now while I work on this other section. The code is still there. You can see from the dots that the code is still there, and we can always expand it whenever we like. Okay, so pretty much covers the basics that I wanted to cover. Really important. Don't forget about view, restore layout. If your layout gets really wonky, just go back to view and restore your layout and you're good to go. As far as creating workspaces and creating projects, we've already done that before in the installation videos, so that should be pretty straightforward. If you have a workspace open and you try to create a new one, it won't let you. Make sure you close the workspace first, and then you're allowed to create one. So here's a section 19 workspace. This is a workspace we're going to use later in the course. Let me open it up to give you an example of a workspace with a bunch of projects in it. So you can see section 19. That's, again, later on in the course, this is the section we're going to use. And this is the section on I/O and how to use files and how to do things like that. So we've got a lot of different projects in here. Each one has a description, main CPP, and this is some of the code that we'll write later on. I know it looks maybe a little bit daunting right now, but don't worry, it'll be fine. I can close that up. And in this case, challenge one solution is the default project. Here is the challenge one solution. So there's the code, and you can see here where it really is useful to use code folding and fold some of this stuff and kind of get it out of the way. So for example, there's my main. That's my whole program, right? But let's say I only want to look at structs and I'm only looking at my structures. So they show up really, really cleanly without going through hundreds and hundreds of lines of code. In this case, that's my challenge one solution. Suppose I want to run it. Well, I'm going to come to build. Remember, it is the active project because it's bold and italicized. I'm going to go to build. I'm going to select rebuild project. You can see my output view down here. It's doing G++exe. It's using everything I need to use. Then I'm going to come to build, run project right there. Just execute. I'm going to get a command prompt window, and that's the output from this program that we're going to do later on in the course. Okay, so that's it. This gives you a pretty good feeling for the interface, the entire CodeLight interface. There's a lot of stuff I didn't cover, obviously, but I'm not going to use any of that stuff that I didn't cover in the course. IDEs, as I said, are usually used for very large programs, but they can also be used for small programs. We're just not going to use all the bells and whistles. So if you have any questions, please let me know, and I'll see you in the next video, and we'll start coding. In this video, we'll write our very first program. So what we want to do is we want to create a project. So again, I'm in the section 4 workspace, and I'm going to right click on there and say new project. I'm going to select my default template again, and I'm just going to call this first program. And I'll select next and finish. Now notice that project 1 is the active project, so I want to be sure that first program is the active project. So I can just double click on it. And I can open up that C++ file. That's it. So this is the source code for the first program. Now, what I want to do is I want to erase this, and I want you to really just type it in. That way you get used to typing these things in at the beginning, and that's probably the best way to do it, is just to follow along. So let me tell you what this program is about. This program is going to ask the user to enter their favorite number, a number between 1 and 100. And then it's going to display, wow, that's amazing. That's my favorite number too. That's it. Okay, so let's start. First thing we need to do is we need to do #include of IO stream. Now, as I type, I'm going to press IO. Then when I press S, you can see that the code completion is helping me out. It's trying to figure out what I want. And it's giving me its guess as to what I want. And I want IO stream, so I'm just going to select it and close it. There is no semicolon here on this statement. These pound directives, and we'll talk more about what these preprocessor directives are in section 5, but they don't take semicolons at the end. So I'm going to press enter. And now we want to create our main function. Remember, the main function is the main entry point. This is the place where execution begins. So we're going to say int main left paren right paren. And then we're going to put a left curly, and the IDE will terminate that left curly with the right curly. We'll talk more about style as we go, but some programmers like to line up their braces like this. Others like to line them up like that. Right now, it doesn't matter. Let's just line them up like this. All right, so what do we need to do? We need to prompt the user to enter their favorite number. So how do I do that? I do that with a cout statement. So I'm going to say std, 2 colons, then cout, and we'll do the insertion operator, which inserts something into that stream. Remember, cout is typically tied to your console, your terminal, so the user can type things in. And we're going to display, enter your favorite number between, let's say, 1 and 100. And I'll just put a colon there. Now you'll notice that you've got a quote mark and then a terminating quote mark. This is called a string. This is called the string literal. This will be displayed exactly as is. Now, this is a statement, so all statements end in a semicolon. Remember, main returns an integer, and that integer is 0 if everything is good. So I'm going to return 0. Right? So if I run this program now, it's all it's going to say is enter your favorite number between 1 and 100. That's it. It's not going to grab the number from anywhere. It's not going to display anything else. We need to somehow read what the user types in on the keyboard. So just like cout writes to the console, cin reads from the console. So what we're going to do here is we're going to say std cin, and now we're going to use the extraction operator because we want to extract information, and it's the same as the insertion operator except going the other way. But now what we're saying is we want to grab whatever the user types in and we want to store it somewhere. Where do we store that? Well, this is where variables come in, and we'll do a lot of talking about variables in section 6. I'll talk about how do you declare them, how you initialize them, the rules for naming them, and so forth. But declaring variables is very straightforward, so let's do that here. What we do is we tell the compiler, remember the compiler is really dumb, it's not guessing, it does exactly what we tell it to do. So what I'm going to do is I'm going to tell it that I want a variable name, and that name is called favorite number. That's where I want you to store what the user typed in. And you also have to tell it what kind of data that is. Is it a string? Is it some big, huge structure? No, in this case, it's just a whole number, an integer. So we're going to say int space favorite underscore number semicolon. That's it. That's a variable declaration. You've just told the compiler that this variable name right here, favorite number, is an integer. Now I can read information into that. So I can say std, 2 colons, and again, the std will explain later on, it's a namespace, but we definitely need it here. std cin into favorite number. Now again, I'm going to type fav, and the code completion will try to figure out what I want, so it's going to use favorite number. I can just press enter. Semicolon on the end. So notice what we've done so far. We've included IOStream. Why did we include IOStream? Because we need the input-output libraries. We can't do IO without it. So we're including it. Now the compiler understands about input and output. It understands cout and cin. They are defined in here. Great. So I'm outputting, enter your favorite number between 1 and 100. Now the user is going to type something at the keyboard, and whatever they type, we're going to store it into favorite number, this guy right there. Right now, we just need to say cout, and I can say something like amazing. That's my favorite number too. Here we can do an end line, so we flush the buffers and print out to the next line. That's it. So let's go through this again one more time. We've got a main function. This is the entry point. This is where execution begins. All C++ programs must have a main function. All C++ programs must only have exactly one main function. So when the program begins to execute, this is where it starts. Here I've defined a variable called favorite number, and it's an integer. It can only hold whole numbers. I'm outputting to the console, enter your favorite number between 1 and 100. The user's now going to input something into the console, a number, and I'm going to read it and store it into that location, into that variable, into that box. Then I'm going to say cout, amazing, that's my favorite number too. And I'm just going to print end line at the end that'll flush out the buffers and move the cursor over to the next line. Finally, I return 0. Everything's good. Now, next thing to do is to build this program. Program's not going to run it by itself. We need to compile it, we need to link it, and then we need to execute it. That whole process of compiling and linking is called building. Now you'll notice that when you right-click on that source file right here, main CPP, you see it says compile. Now if I press that, it's going to compile our program, and you can see here, 0 errors, 0 warnings. We'll talk about what happens if you get errors and warnings a little bit later. Also notice that we're using the C++ 14 standard, which is what we want to use. That's what we did when we set up that default template, if you recall. What we need to do next is to build the project by compiling and linking. That's going to create the exe file on Windows or the executable files on Linux and Mac. And we'll do that in the next video. In this video, we'll take our first program, which we've compiled to show that it's got no errors, and we'll build it. Now, if you recall, building means compiling, linking together with extra libraries and external files if we need to, and creating an executable file. That's what building is all about. There are several steps involved with building. The first one, obviously, is compiling. If we can't get a clean compile, then there's no way we're going to build the system. So we want to be able to compile and then link to create the exe file. Finally, we can run our executable. So in this case, you'll notice here's the source code. And there's a lot of space in here. Normally, we don't have all this space in here. I just put it in because it makes it a little bit easier for you to read when you're first learning. So let's just keep it like that. This program is exactly the same as it was before. We're asking the user to enter their favorite number between 1 and 100. We're getting that number and storing it in a variable called favorite number. And then we're just saying amazing, that's my favorite number too. So it's really, really simple program. And we've already compiled it. There's a couple of ways to compile. One is you can come to the source file itself, right-click, compile, or you can come up to build, compile current file, and that's only taking care of the compilation. There's also a lot of things you could do at the project level right here. So if I select the project and right-click, you can see that it says build, rebuild, clean, stop build, and so forth. Let's talk about clean first. Now, think about this. When I compile a C++ program, I'm converting the CPP source code, this source code you see here, to an object format, right? A machine language or a binary format. That's going to create a .o file or a .obj file, as we mentioned in the previous lectures. That's the purpose of compiling. Now, as your programs are compiled, they will have many of these .object files. The clean process removes all those object files and puts your project in a clean state. In other words, source code only, no object files. Now, why is this important? It's important because when you compile your programs and build your programs, sometimes you want to do a clean build. What that means is I want to start from a position where nothing has been built. I just want to clean everything out. Now, when we're working with a single CPP file like here, it's pretty much a moot point because it's just one file. But typically, C++ programs are very large, and you've got a lot of C++ files. Each one of them is being compiled to an object format. And when you say, hey, compiler, build for me, the compiler's only going to build exactly what it needs to build. So if it realizes that this source code already has an object file associated with it, and the source code hasn't changed, then why bother building it again, right? So it's not going to build it. And it does that to be efficient, which makes a lot of sense. But occasionally you want to do a clean that removes all of that stuff. It removes the exe that was created. And then you want to build again. So now we're going to get a clean build. Again, this is really not an issue here when we've got one CPP file. But if you've got thousands and thousands and thousands of files, there can be a significant difference in the amount of time that it takes to do that build. Okay, so in this case, I can come over here to the project. I could right click and I can say clean. And you'll see here the clean is complete. All it did was remove any object files and the exe files. Then I can say build. Now, when I say build, by saying build project here, pressing F7, or on Mac, whatever the command option is, or I can right click on the project and say build. Now what's going to happen here is it's going to go through your project looking at all the C++ files and only build what it needs to build. Okay, now in this case it's going to build everything because it's just the one file and I haven't built it yet, but it's going to not build what it doesn't need to build, and that's important to understand. Rebuild is the combination of a clean and a build. So when you say, hey, rebuild the project, it's going to do a clean, it's going to clean everything out, and then it's going to build it again. For the beginning of this course, all of these are going to be just fine. You can use rebuilds because it's going to be pretty quick. Finally, once we get a build, we can run the project. The way we do that is we come up, again, remember we've got the active project here. I can come up to build and run. Now, if I do that now, we have an option. We can simply execute the exe file if there is one there, or we can choose to build and execute. I would generally tell you to select build and execute and probably remember my answer. Don't ask me again. It would be a pretty good idea because most of the time our files are going to be fairly small and a build is not going to take any time at all. So we can build and execute. Okay. So that's how you run. Let's say I want to do that now. I'm going to say build and execute, and there's my program. It says enter your favorite number between 1 and 100. Let's say I type in 24, press enter. It says amazing, that's my favorite number too. Now this time elapsed is how long the program took to run. This is being displayed in the latest version of CodeLight. Prior to this last version, you didn't see that, and I think it's Windows only it's being displayed. I didn't see that display on a Mac. When you run the exe file that's created from the command line, you don't see that. That's just mostly for FYI, so that you can tell as a developer, if there's something wrong and how quick your program's running. Press any key to continue. I'm done. Okay. Now, one of the things that I want to show you, notice this workspace view, which is where I'm at right now. And again, I've got 3 projects here. Each one has a main. Where's the exe files? Where are the object files? Where's all that stuff? They should be there, right? Absolutely, they should be there, and they are there. The IDEs generally hide that information from you because you don't need to know about it, really. I mean, do you care that there's an object file or an exe file? Really, what you care about is these error messages and so forth. But we have this Explorer tab, and that'll let you see all that. I want to show you what that looks like. You can click on the Explorer tab, and then you can drag any folder from your operating system, from your file system onto here. So I can just right-click, open folder, and I'm going to select from my desktop CPP examples, that section 4 folder. That's where my workspace is, and I'll select it. Okay. So you can see now, if I expand this, you could see a bunch more stuff now. I've got a .codelight folder that has things that are related to my favorites and compilation and refactoring and so forth. I've also got my 3 projects, first program, project 1, project 2. I've got a make file, I've got my workspace file, but let's look at first program for a second. Now you can see a little extra stuff going on, right? Before all we saw was main CPP, now we see all this other stuff. These are the files and the configuration files that CodeLight is using behind the scenes. The IDE workspace here abstracts that out since you don't really need to know all that information to build your system. It's building it for you. But if you really want to see them, you can, or you can just look right in your file system. Now, if I look in my first program debug folder, you'll see that there's my exe, first program.exe. You can see it right here. And there you can see my .object files and .d files and all kinds of stuff that's going on. Now you'll see first program debug. Now what I'm going to do now is I'm going to clean first program, and all of this stuff should be removed. Okay. So again, I'm going to go to build, clean project. Now, if I refresh this view by right-clicking up here, refresh, and go back to first program, you can see it's all gone. The entire debug folder is gone, the object files are gone, the exe files are gone, everything's gone. So now when I rebuild, all that will be created again. And now you'll notice that debug folder, right? Well, if I come back to my workspace, there's my first program. Notice that we've got build configurations here. There's a couple. You've got debug and release. You can choose either one. We're going to use debug throughout the entire course because that's what we're doing. We're basically developing right here. Release is when you want to release the file to production for your users to use. So in this case, debug creates that debug folder that you saw a little bit ago. If we do this in release mode, we'll get a release folder as well. So we'll have two EXEs. Now the difference is the debug configuration creates object files that has debugging information in them. It's got all those variable names and stuff. So later on when we debug our program, we can have all that information available to us, and it makes us very, very productive, and it really helps us debug and test our code. The release configuration removes all of that stuff, and it does more optimizations, and it just makes your EXE leaner and meaner so that you don't need all that debugging information at runtime. Okay, so like I said, we're going to use debug. You can certainly use this if you like. If you do use this because you're curious or you want to see what's going on, don't modify anything from in here. I mean, as a matter of fact, if I try to open up this make file, you'll see it says auto-generated by CodeLight. Don't change it. Or even if you do change it, we're going to blow it away anyway. And so you really don't need any of that. This is where we're going to be working in the workspace mode, but I just wanted to show you how that clean really, really works. Okay, so again, let's recap here. I can select first program, right click, clean. That'll remove all my object files in the exe file. I can rebuild, in which case it will clean and build, or I can simply build, and that will only build what needs to be built. Okay, hopefully that makes sense. It's a little difference between them, but you should understand it's not that big a difference. Now, finally, we want to run. We come here to run. So let's do this one more time. I'll build and execute. Enter your favorite number. My favorite number is 100 this time. Amazing, that's my favorite number too. That's exactly what our program is supposed to do. Now you'll notice a couple of things here. One is, we're really not using favorite number, are we? I mean, the user's typing it in, but we're not really saying, wow, that's a great number, 13 that you entered, or 100 that you entered. And you'll do that in the challenge exercise in this section. But right now, we're grabbing it, we're storing it into that variable, but we're not really using it afterward. And like I said, in the challenge video, you will use it. So that's it. That's pretty much the build process, the compile process, the run process. It's fairly straightforward. If you've got the toolbar, you can click on buttons to do this. But in this course, I'll come up here and do these things, or I'll just right click here and do what I need to do here as well. That's it. Remember, you can also come up to the workspace and right click on the workspace, and you can build the entire workspace or clean the entire workspace. And that'll create exe files for all the projects all in one shot. Okay, that's it for that. Now in the next video, what we'll do is we'll talk about compiler errors and compiler warnings, and we'll mess around with this program a little bit. And I'll show you some of the common errors and some of the common warnings that you could get, as well as why they happen. Now, throughout the course, we're obviously going to see a lot of compiler errors. I make it a point that when I teach, I'm just coding along with you. So I hope I make some mistakes so that you can see some of the common compiler errors. I'm not trying to make them intentionally, but sometimes, you forget a semicolon, or you forget to do this, or this is the wrong type. So that's important that you see these types of errors happening and you can know how to fix them. All right, so I'll see you in the next video. In this video, we'll talk about compiler errors and why they can happen. Programming languages have very specific rules about how to write code so that the compiler can translate that code to machine code. These rules involve both structure and meaning. For example, C++ says that all variable declarations must end with a semicolon. If we don't add the semicolon at the end, or we put it in the middle instead, then we have a syntax error. The compiler is complaining that the structure is not correct. In the first example, we didn't terminate the string error with a trailing quote character. In the second example, we left out the semicolon at the end of the return 0 statement. Both of these are syntax errors. There's something wrong with the structure of the code. Now, these syntax errors are pretty easy to fix, and the compiler errors usually give us pretty good information about what's going on. Semantic errors are a little different. In this case, the syntax or structure is correct, but the meaning of the code doesn't make sense to the compiler. Suppose we want to add two variables, a and b. If the variables are both integers, then this makes perfect sense. But what happens if one of the variables is a person and the other variable is an integer? Does it make sense to add a person and an integer? Probably not. In this case, the compiler generates an error. When we think of compiler errors, we really think about both of these classes of errors. Remember, compilers are very, very picky. Why? because their job is to translate your code that you wrote into machine code that functions as you said. If the compiler has any problem understanding the meaning of your code, then it won't guess. It will generate an error. Let's head over to CodeLight and see some of these errors. So now I'm in CodeLight, and I created a project called Compiler Errors. And I created it right from our template. So it's just a simple hello world program. It's just printing out hello world. Okay. Now what we want to do is we want to introduce some compiler errors into this program so you can see what they're like. Now let's do some syntax errors. Simple stuff like, okay, we forgot this quote right here. And I can save and compile, and you'll see that I'll get an error that says missing terminating character. And if you click on here, it takes you here. Okay. Now, in this case, we've got another error that says expected primary expression before return. This happens sometimes. The compiler gets confused. It sees that first error, and then it's trying to figure out what's going on, and it goes to the next line, and it says, I don't know where I'm at, and it creates an error. Many times when you fix that first error, many of the subsequent errors go away. So let's put that quote back in. We'll save, and let's recompile. Now we've got a clean compile. So that would be my, my advice when you're first learning. Start out at the beginning, get that first syntax error fixed, recompile, and very likely a whole bunch of other errors just went away. Okay, so that's an example of a syntax error. The compiler is expecting a string, and it knows it's got a rule that says all strings have to have a quote character, a bunch of characters, and then a quote character at the end to terminate it. It didn't see that, it didn't like that, and there's the syntax error. Really easy to fix. Other times, you may have things that are misspelled. So for example, let's say I spelled end L here wrong. I put an extra L in there. Now when I compile, it's saying error, end LL is not a member of the standard namespace. So it knows that cout is and end L is, but end LL is not. So in this case, this error message kind of leads you to the place where the problem is, and you say, oh, of course, I have a typo. So you can fix that as well. Okay. Another example of a compiler error that's a syntax error is forgetting the semicolon here, let's say at the return 0. All statements have to end with a semicolon, so we just forgot it. That violates one of the rules that the compiler knows about, and it doesn't like it. So what we'll do here, again, we'll compile. And you can see it says error expecting a semicolon before that curly. So there's the curly, and it's expecting a semicolon. Sure is because of that. Okay. Now suppose we just say return, semicolon. Now this is problematic because we've told the compiler in our code that main returns an integer. But here we're just returning, we're not returning an integer. So let's see what it says. Let's compile. And it says error return statement with no value in function returning integer. Pretty good statement, right? It's telling you I've got a function. You told me it's returning an integer, but you're not returning any value now. So I can return 0. Okay, so let me show you an example of a semantic error. Something like this. This is perfectly valid. I can return an integer, I can return a string, I can return a lot of things. The problem is that it doesn't make sense to the compiler because you've told it here that you're returning an integer, but now you're returning a string. So let's run that and see what you get. Here you go. Error, invalid conversion from a character star, which is a string, to an integer. So the compiler is trying to figure out, how do I convert that Joe to an integer? I don't know. I have no idea. I'll just throw the error. Okay, and that's up to you now to fix it. So in this case, again, I'll fix it to return 0. Now let's do another one. Let's get rid of that first curly. This is a real interesting compiler error, and I'll compile it and then we'll talk about it. Let's compile, and you can see that I've got 3 errors from that. What's happening is the compiler is totally lost here. The compiler is seeing int main, and then it's expecting a curly, and it's processing more and more stuff, kind of hoping to see that left curly eventually, and it's not seeing it, so it's seeing other things, and it's throwing errors. It's saying, I don't know what's going on before the STD. I've got an unexpected, unqualified something before return. I'm lost. Okay, so when you see these kinds of errors, I mean, this is a tiny little program, and I've got 3 compiler errors. Sometimes you'll compile something, you'll get 20, 40 errors, and many times when you fix that first one, most of them will go away. So in this case, all that's missing is that that curly. So I'll compile, and we should have a clean compile now. No, we do. Okay. Sometimes you'll add extra curlies at the end, which again is illegal. So I'll compile, and there it is. Right? Error. I'm expecting something before that token. It doesn't know what you're doing. So we'll get rid of that. Okay, so let's do one more semantic error. Let's say that we've got hello world in here, and I'm going to put parentheses around it, and I'm going to divide it by 125, and I'll put a parenthesis around that. Just simple math. Okay, that's pretty weird. I've got something here divided by something here. That's valid. I can divide two things. The division operator, which is that slash, is a binary operator. It works on two things, right? So 4 divided by 2 is 2. 8 divided by 2 is 4, and so forth. But in this case, the syntax is correct, but the compiler is going to say, I have no idea what you want me to do here. You're telling me to divide hello world by 125? I don't even know what that means. So let's compile that. And the error is something like error invalid operands. So the division operator, the slash operator, has got invalid operands. There's two operands, right? One is a string, the other one is an integer, and it's saying, I don't know what to do here. Okay. So these are some simple examples of compiler errors. Don't be afraid of the compiler errors. You're going to get them. Don't let them frustrate you. If you have any that you can't figure out, please post to the forums, and I'll be glad to help you out. It's just something that we have to learn to work with because we're going to get compiler errors. We all make mistakes. Sometimes we're prototyping, we're trying new things, and we're getting errors. Sometimes they're just silly mistakes, and they're hard to find sometimes. Sometimes you'll be looking at your own code. I can tell you, this little error here with the end double L, this is a good error message that you got. But if you're looking at this code, and you've been coding for a few hours, I don't think you'll see those two L's. Most likely, they look like one L. So this is the kind of thing that programming is about. One of the important things is getting rid of all these compiler errors. Once we get rid of the compiler errors, then we can test our code and we can look for logic errors and so forth. Okay, so that wraps up this video. In the next video, we'll talk a little bit about compiler warnings. They're a little bit different from errors because they're not true errors, but they're telling you something that you should look out for. In this video, we'll talk about compiler warnings and why they happen. Big tip, don't ignore compiler warnings. We'll talk more about that in a minute. The compiler has noticed a potential problem in your code and it's warning you about it. That's what compiler warnings are all about. It's only a warning because the compiler is still able to understand your code and produce object code from it. However, it's letting you know to be aware that something could be problematic. In this example, we've declared a variable called miles driven, and it's an integer. It can hold any kind of whole number. Then on the next line, we display the value of miles driven to the console. The compiler produces a warning here. It's warning us that you've used the variable miles driven, but you never initialized it. So in other words, the value that it contains could be anything. Once again, don't ignore compiler warnings. Many programmers treat them as errors and fix the potential issues up front. Let's head over to CodeLight and we'll see some of these warnings. So now I'm back in CodeLight and I've created a project called Compiler Warnings. And again, it's a default project, just simple hello world. Now what I'd like to do is, let's use that favorite number variable again. So let's create that here. I'm going to say int space and the name of my variable. Let's call it favorite number. Perfect. Now, suppose I want to print out that favorite number. So I'm going to remove this hello world right here, and I'm just going to replace it with favorite number. So that's all I want to do. I've got a favorite number. I'm going to print it out. Now, if I try to compile this, syntactically, there's nothing wrong with this program, but there is a problem, and the compiler's warning you right here. It's saying favorite number is used uninitialized in this function. So in other words, you haven't told the compiler what the value of favorite number is. You haven't asked the user to input anything into favorite number, and you're going to print it. The compiler's telling you be careful because anything could print here. And in this case, anything will print here. So let's run this so you can see what it looks like. I'm going to run, I'll build and execute, and look at what favorite number is, 4200971. Probably not what you expected. That's the reason for the warning. The compiler is telling you, you never set that variable to any specific value. So when I print it, who knows what's going to be in there. Okay, we'll talk more about that when we talk about variables. So that's one of the issues that you could have. Another issue you could have is, let me go back to Hello World here. Another issue you could have is, suppose that in this case now, we do assign something to that favorite number. Let's just say favorite number is, I don't know, 100. So look what we've done now. We've created a variable, we've assigned a value to the variable, but we haven't used it. So the compiler's thinking, wait a minute, did you plan to use that variable? Why did you create a variable and not use it at all? So we'll compile, and the warning is variable favorite number set but not used. Okay, so it's telling you, are you sure you want this? There's no reason for you to create a value and then not use it. And similarly, if I get rid of favorite number here and I just do something like that and compile, there's the warning again, unused variable. You've created a variable, but you haven't even used it. So what do you want? The idea is you should have a no warnings policy in your code. You should have clean compiles with no warnings. Now there's many, many more warnings, and we'll run into them when we talk about if statements and looping and assigning and doing math. And we'll talk more about those warnings when we get there. In this video, we'll talk about linker errors and why they can happen. Linker errors occur when the linker is trying to put all the pieces of a program together to create an executable, and one or more pieces are missing. Typically, this can happen when an object file or libraries can't be found by the linker. Fixing linker errors can be tricky. Sometimes it's just a matter of getting the paths correct so that the linker knows where the missing pieces are. Let's head over to CodeLight, and we'll force a program to have a linker error so you can see what the error message looks like. So I'm in CodeLight, and I've created a project called linker error based on the template that we use. So all I've got is a main CPP file that says hello world. Now we're going to force a linker error here. This is not something you want to do normally, but I want to do it to show you what the error looks like. So what I'm going to say is I'm going to say extern int c, or let's just say x. And I'll explain all this to you in just a second. And then in the body of the main, I want to try to use that x right there. It's just an integer, and let's say I want to print it out. I just want to print out x. Simple as that. I'm going to save this. Now you'll see if I compile this program, you'll see what happens. I'm going to right-click, compile. I get a clean compile. There's nothing wrong with the program. Okay. But when I try to build and run it, you can see the linker error. This is classic linker error, undefined reference to something. In this case, it just happens to be x. Also, you'll notice that the linker returned 1 here. LD returns 1, which is the exit status. So something was wrong with the link. Obviously, the compile was fine because we got no compiler errors. Right? You do that again, there's the compile, no errors, no warnings. So let me explain to you what's going on here. Let me grab my stylus here real quick. And what's going on here is I've got my main CPP file here, and it's going to be compiled to main.o, let's say, or main.object. In here, we have a reference to an x. You can see it right there. You can see it right there. So in here, I've got a reference to an x, which I'm going to use. Now, we also have our IOStream libraries. So the linker needs to grab those libraries, and I'll just type IOStream here so you'll know what I'm talking about. The linker needs to put these two together to create my main.exe. Or in this case, I believe it would be linkererror.exe, but you know what I mean. So the compile is fine. We've created our object file. This library exists. The problem is that I've told the compiler here that this x is not in me. It's somewhere else. It's defined by somebody else. Well, obviously it isn't defined by someone else because that kind of forced the issue here. So now the linker needs to resolve that x. It's saying, okay, where do I get that value to print? Because that's what you asked me to do right here, right? I wanted to print the value of x. Well, where is x? It can't find it. That's the linker error. That's exactly what's going on. And let me build this again so you can see the error message one more time. Let's build it and run it. And there's the error message. It's saying undefined reference to x. You can see exactly what's going on. It can't find x. Now, this is not a compiler error. This is a linker error. That's real important to understand. Linker errors are tricky to fix. A lot of times the files that you need to link are missing. They're in the wrong places. You don't have to worry about that using CodeLight. In this course, we're going to basically do everything ourselves. But if you're using libraries from third parties, this is the kind of thing we'll talk about in a more intermediate or advanced course. But I just wanted to show you linker errors in case you do come up with one. Post it in the forum and we'll work through it together. In this video, we'll talk about runtime errors and why they can happen. As the name suggests, runtime errors are errors that happen when the program is executing. These types of errors can be difficult to predict when we're writing our program. These errors include divide by zero errors, file not found errors, out of memory errors, and many, many more. Some runtime errors can cause your program to crash. We use exception handling to help us know when runtime errors happen so we can try to recover from them. We'll see examples of runtime errors later in this course when we work with files. We'll also work with exception handling toward the end of the course. In this video, we'll talk about logic errors and why they can happen. Logic errors are errors or bugs in your code that cause your program to run incorrectly. Logic errors are mistakes made by a programmer. Sometimes the mistakes are careless, other times the mistakes are because the programmers have incomplete or incorrect information. Other times mistakes occur when one programmer modifies another programmer's code to fix or add something, and they introduce an error as they do this. There are many, many causes for logic errors. It doesn't matter what the cause is, though. They need to be corrected. We need to test our code and debug it to find and correct errors. Suppose we have a program that determines if a person can vote in an election, and you must be 18 years old or older to vote. We haven't talked about if statements yet in this class, but they're very intuitive, and I'm sure you'll follow this little piece of code. First, we test to see if the age is greater than 18. If it is, then we execute the code that's inside those curly braces. Do you see the error? It's pretty easy to see it here because the code is isolated, and I told you there was an error. However, in reality, there's much more code typically involved, and this may just be a small part of a much larger program. The problem in this code is that the test condition should be greater than or equal to 18, or greater than 17. Either one will work. As it's written now, 18-year-olds would not be able to vote. We'll talk about testing throughout the course in the context of learning C++ and best practices. Well, that wraps up this section. Next, you can take the section quiz and attempt the challenge exercise and see how you do. I'm sure you'll do great. If you have any questions, please post them to the course forum. Welcome back. So you're ready for the section challenge. Let's go over the challenge. Create a C++ program that asks the user for their favorite number between 1 and 100. Then read this number from the console. Suppose the user enters number 24. You want to display the following to the console. Amazing. That's my favorite number too. That's exactly what we did in our first program. Now here's the little bit of a twist. You also want to display, no, really, 24 is my favorite number. Below are two sample runs of the program. So in this case, we're prompting the user. There's our prompt. The user enters 24. And we print out amazing. That's my favorite number too. No, really, 24 is my favorite number. And if I run this program again and I type in 75, I'll get 75. So let me run the program for you so you can see what it looks like. Here we go. This is the prompt to the user. Enter your favorite number between 1 and 100. So let's say I typed in a 50 and press enter. Then you're going to display to the user, amazing, that's my favorite number too. No, really, 50 is my favorite number. That's it. That's the challenge. That's it. That's the challenge. Give it a shot and then come back to the next video and we'll work through the solution together. Welcome back. I hope you were able to solve the challenge. Let's go over it together and I'll give you my solution to it. This is a pretty simple challenge, but it's important that you get it because we have to be able to compile, build, link, and run. Obviously, we don't want any compiler errors. We don't want any compiler warnings. So let's start here. What I've done is I've created a challenge solution project based on the template. And here's my main CPP. It's just a simple hello world. So this is the one I'm going to modify. All right, so let me change a little bit of this. I'm going to get rid of that statement right here, and we'll totally start from scratch. Now remember, we need to include the IOStream library. This is how we do input and output. This is how we do our cins and our couts. So First thing I want to do is I want to prompt the user. I want to say std, 2 colons, and cout. And there's my insertion operator. I'm just going to simply say enter your favorite number between, let's say, 1 and 100. And we'll put a colon there and a semicolon on the end. That will prompt the user. Okay. Now we want to be able to read that number from the user. Remember, when we read something, we need to store it somewhere. So we need to store that in a variable. In this case, it's going to be a whole number, so we're going to use an integer. So I'm just going to say int favorite number, just like we did with that first program we wrote. So that's my favorite number. Perfect. Now I can read into that variable. So I can say std from cin. I want to extract, so I'm using the operator going the other way, into favorite number. Okay, so at this point, I've prompted the user. They've typed in a number. I've read that number, and I've stored that number in this favorite number variable right here. The last thing to do is to print out those 2 statements. So first I'm going to say cout, and I'll say amazing. That's my favorite number 2. And we'll print a new line here so we can go to the next line. We'll say endl, followed by a semicolon. And this is the only difference now between this program and the one that we wrote previously. We want to be able to display the number. Say, no, really, whatever you entered was or is my favorite number. So in this case, let's do that again. We'll do std, and we'll do again cout, and we're going to write to that stream. And I'll say, no, really. And I'll put a comma here followed by a space because we want this to be spaced out nicely. And I'll show you what the problems may be if you don't do that in a second. And at this point, we're going to insert our favorite number right in here. And we'll do another insertion operator. Remember, we can stream all these things together. We can do as many as we want. And we'll say space is my favorite number. And we'll finish it off with a new line. Let's try that. We'll go up to build, run, and build and execute. We got a clean compile and it's running. Enter your favorite number between 1 and 100. Let's say it's 10. Amazing, that's my favorite number 2. No, really, 10 is my favorite number. Perfect, that's exactly what we wanted to solve. Now, the reason that I put in these little spaces here is because let's say I don't put that space in there and I don't put the space in here. Just like that. And let's run this again now. You can see that the output's not going to look right. So in this case, let's say I typed in 25. And you can see, amazing, that's my favorite number 2. That's fine. But now look, no really, comma 25, no space between 25 and the little I for, and the lowercase I for is my favorite number. So you can see that the output doesn't really look very nice. So all we're doing is just formatting it. We'll talk more about writing to streams and using manipulators so that we can really get more fine-grained control of what we want this to look like. But for now, we could just put spaces right in here. And we'll try that again. Build and run. My favorite number is 10. No, really, 10 is my favorite number. Perfect. So that's it. And that's the solution to this challenge. As I said, it's a pretty simple challenge, but there's a lot of pieces here that come together. In the next few sections, we'll talk about the structure of the C++ program, as well as variables. We'll talk a lot about variables, how we declare them, how we define them, how we initialize them, and how we use them. But you got a taste of it here.